Hi, today I'd like to design one of those nightlight circuits that turns on the nightlight when the room gets dark. I came up with a simple circuit. It reduces the AC level and rectifies it with the full bridge rectifier, which is really just called a bridge rectifier. It powers the circuit which senses the light and switches light on and off. Please see my website electroboom.com for more details on the circuit. This circuit is a bit of an overkill because it's an industrial grade nightlight. Imagine a Hells Angels biker wants to stay overnight in an abandoned factory and he's scared of the dark, so he uses this circuit. Here's my creation. Let's plug it in. Amazing. Usually shit goes haywire at this point. Oh, I forgot to turn on the... What the f*** was that? I said I'm sorry! Always double check and triple check your circuits to make sure there is nothing shorted, especially when dealing with power circuits. I fixed it. Let's plug it in. Turning the lights off. The hell? Nice, I added a feature, it's blinking. Oh, I know. See, it's feeding back into the circuit. What happens is that when the light turns on, the sensor sees light and turns off its output. And when the light turns off, the room gets dark, the sensor turns it back on again and the loop continues. Now if I cut the feedback by blocking the light, it stays on forever. It's working. Now let me discuss the power supply side of the circuit and show you some waveforms. As I showed earlier, the first stage is a capacitive voltage divider. Now if I probe the input AC... I have mentioned it before. The ground of the probe is shorted to the earth terminal of the power plug through the scope, and this circuit is pretty much riding on the live wire. So when you connect your probe ground to this circuit, you're just shorting the 120 volt AC output. It is a safety feature, but for application like this, you need to insulate your earth. So you can put some tape around it or use an insulating transformer, which I don't have. Okay, here's the 120 volt AC input to the circuit. And this is the output of the capacitor divider, and as you can see it's much smaller. Let me zoom in. You also see that it's a little bit deformed because it's loaded by the circuit. Now if I measure the output of the rectifier, it is AC. Oh, the ground. That's AC too, what the hell? Something I forgot to mention is that the rectifier output is only DC between its power and ground output, not reference to the input wires. So I have to move the probe ground to the rectifier output ground, which is, I think, this... You might want to turn things off before moving things around to avoid shorts. Okay, fixed. Now this is the output of the bridge rectifier, which is around 13 volts, but it can change to around 7 volts depending on the loading of the circuit on the voltage supply. Now I feed that voltage into my 5 volt regulator, which provides a fixed 5 volt output and doesn't change by input fluctuations. And that supplies to my sensor circuit, and the sensor circuit turns the light switches on and off. That's it, I'm done with this circuit. It's all fixed and functional, so I'm gonna pass it on to one of my eligible patrons at patreon.com. If you also like to support my channel, you can go to patreon.com/electroboom. Become my patron and potentially win one of these giveaways. Potentially, get it? Because everything is potentially charged around here. Which means that this might be a liability to send to anyone. It's like sending anthrax by mail. Well, I'm gonna send it to the draw winner anyways, but it's for educational purposes only, right? So if you kill yourself using it, don't go around and badmouth me, okay?